Hello friends, welcome to FoxuTech. So this is new series we'd like to start, and it will be like one another video. We may do it on random along with our other technical series. So this will be the new series like a Kubernetes troubleshooting topics. So we'll be covering one another interesting topics, how we can troubleshoot Kubernetes issues, whatever the issues comes are the most common issues raised. And in this we will be not only is so the series will be covered most of the famous issues and how we can troubleshoot and what are the things we should consider when we are focusing on the fixing the issues, right? So this is the first series, and in this we're gonna discuss just we'll give you the brief about basics. What are the things we should do before we are doing any kind of a troubleshooting, right? What are the things we should aware, and what are the things should be in place to make sure our troubleshooting goes very fine, right? So let's start. So let me break you down the things whatever we are covering. So the first topic is we're gonna cover about SREs and the signals whatever they are using, and in that we're gonna cover some golden rules or the incident responses whatever we are using. And once it's done, so we're gonna see about logging options, what are the logging option it gives, and what are the monitoring tools we gonna use it, or how we can configure it, right? So it's related to some basics things we will be covering. So we don't go depth on each topics, but we will give some hints to you. So from that we'll take it forward, and one by one the troubleshooting section we will be detailing in very deep, right? And also we can see about the health checks. So we seen the last video about health checks, and hope that gives more ideas. If not, please check again. So in this we're gonna say like what are the available checks and why it's important. So once it's done, like and we're gonna say like some of the troubleshooting steps for our health checks, right? So that is the things we're gonna cover in this. So let's move on. So first thing, okay. So before that, we're gonna let's see about what is SRE, right? So that's one of the key things we should understand how the SRE works and what are the things they do for firm. So what is SREs? SRE is nothing but site level engineers. So they are more focused to ensure there is a high uptimes, and also there is a systems or the software or the application, whatever they are managing, they should make sure it gives a high availability systems. And also whenever they are planning for or designing the tool, any kind of systems or applications, so they should always keep the resilience in the mind. So also the monitoring should be very important, so that will help them to troubleshoot any kind of issues. And even right, any kind of a troubleshooting we are doing, not only for the Kubernetes and any kind of applications, so we should be aware of these system details, right? That is our primary role, any application. So if we are serving for any clients, so we should always serve the best things to the clients, right? So for that, these are the things we should always keep in mind and design our environment, right? So what are the concepts it's part of SREs? So when it's SRE comes, so they should always focusing on the moving fast, right? So you can see in the DevOps cycles. So what is the advantage here? So we are more moving very faster. You can see the earlier times, the release, the software release development was so slow, and there is a lot of things they will taken care, and the process, the software to deliver, it takes a lot of time to the market, right? So but when it comes to the DevOps, it was broken lot of parts, and they and you can see the most of the softwares are delivering very quicker and very faster, right? So one of the key backend for that is SREs. So they are making sure like the tools or the softwares, whatever they are doing, it's most faster and without any kind of issues. how they are making sure that, so that will be covered on the monitoring. So that's as we seen, they should always enable the monitoring first place, and also what are the key factors they should consider, and that will help them to deliver this faster. Second thing is automation. So when it's coming automation, we should be considering that high priority. Why? Because that help us to save lot of time and lot of dependencies, or we can say like it will avoid lot of issues, right. So sometimes, let's say like if we are doing manually, and that there is high possible that may not work all the times, or there will be a, or the range of order we may miss sometimes. So those kind of issues will be there. When it's automated, we no need to worry about anything, just single click, it will be running everything, right? So, and next important, very important topics when it's coming SRE is error budgeting. So what is mean by error budgeting? So error budgeting is nothing but, so let's say if you are doing any kind of um, let's say like if you want to deliver the application, and that application should be always available like 100%, that's maybe a theoretically possible, but yes, even though you can enable such options like error budgeting, so which will be calculate your all the details, how long this application should be down, and how much it's going to be cost us, and how the maintenance, each and every points, whatever you are doing in application on the maintenance mode, so that all is counted in this error budgeting. So how your application is designed, and what is the possible of keeping 100%, or what is the possible of serving at least 99.999%, right? So those kind of things will be defined with the error budgeting. So you should define my application will be down for this maintenance for this many time hours, or this many seconds, or this many minutes, like that you should define it first. So based on that, the error budgeting will be calculated. So that you should always keep on high on every aspects. If there is upgrade is happening, how many minutes or second happens. If there is a key change you are doing, migration you are doing, or you are putting any kind of a data migration, any kind of operation you are making, so how long it's going to be affect the application. This will be a down, application will be down, or application will be keep on running, and this will be run back. And so until that is not breaking anything, so it won't be counted. But if something is, there is a high possible of breaking the systems, that will be counted in the error budgeting side, right? So we should calculate that. So we should monitor the hours and everything, and if service can be down, and for also, right, so there will be again, it also given the time periods, so used to no change made. So what happens, so if you are already crossed your yearly budget, say like you are planned for this many times, and there will be a key change you want to make, and that can be wait for certain time, and as you already reached your error budgeting ratio, and in that case you have to hold that future, and you can deliver it later. So those all things will be decided based on this error budgets. And next very important things we should always know about is, whenever you are working, SLAs and SLOs and SLIs. So service level agreement, objective and indicators. So this will help you to suggest whatever the maintenance you are doing, how long your solution is there, and everything will be decided based on this key KPIs, right? So always capture this. So for this, you need to have a proper monitoring system. Until then, you can't do any such numbers. You can pull it out, right? So next topic is let's say like you have a roles, like you have some golden signals, we call it as, in the SRE part. So that is nothing but your latency, traffic, error, and saturation. So these four golden signals are decides about your complete systems, right? Whatever we seen about the concept or SRE or any kind of a topics, we gonna discuss, everything will be decided based on this. So let's see about this one by one. So latency. So latency is nothing but whenever you are hitting any kind of a request and how long it's taking to respond. Always we are in a faster moving world, so we always expect immediate responses, and you should be calculating how long it's taking and where you can take this. So by default, this latency will be calculated either on the load balancer level, or there will be some kind of like if you have some application gateways or any kind of networking layers on top of the application, that will decide as the latencies. So always cautiously calculate this and tune this based for the better performance. Why? Because if there is a delay on any kind of operation, that may delay any a lot of related operations. Let's say like your application is responding slow, and again the db will be slowing down, and your users request will be count will be increased always, and that will hit us very huge issues, right? So that you should measure most effectively, and it should be like a, so you can't, that should be very properly managed and maintained, and also it should be monitored and very accurate ratios and traffic. So that's again correlated here, latencies and traffic. Let's say like you have some better latency, and all of a sudden there is a traffics are getting increased on time to time, right? So with that you have to tune lot of specs, again how much outbound and inbound networking, and how much resources like you are having. So let's say like you design the application for 1,000 users, and all of a sudden there is a 2,000 users are coming up. So what happens? So that obviously your application need a star CPUs and more memories, right? So that will be, you should calculate it very robust, or you should enable some auto scaling options. So with that you should be able to maintain these things. So again, well designed things, these are all the things you should consider in your planning aspects. So next is the errors. So error, it's nothing but here error counts, we can say. So error counts, why it matters. Let's say like your application is giving a per day 2 errors or 3 errors. Like you, it served almost 1,000 plus requests, and there is a 1 or 2 errors. Then it doesn't matter. But let's say like your application is serving just 100 requests per day, and in that there is a 3 to 4 failures or occurs. The ratio is high, right? 4%. When it's 1,000, it's 0.4, but when it's 100, just 4%. Sorry, it's reached 4%. 4% is very high. We should always keep it zero fractions, and it should not be higher numbers, right? So that's why it's always matters. So we should always keep high what is the error, and what is happening across your application. And the saturation, so again your as I told, like latencies or traffic or any errors, so this may happens because of this saturation. Saturation is nothing but you should have like available resources, whether your compute or memory or currently whatever you are using, it's it completely available for the application, or there is any kind of high usages occurred, right? So you should always keep monitor those aspects also, so to make sure any of the one of the key pillar is broken, right? If any one signal or only one of the pillar here out of four is broken, so obviously you will be facing a huge application issues. Okay, and keep some threshold. So any numbers you are keeping, always the best practices, you should maintain a best thresholds. Let's say like your resource computations, right? Keep something between 75 to 80. That will be a best number to start with. It can go still 90. Okay, so but you should not keep the 90 as a base level. Why? Because 90 to 100, it can be reached very quicker, because the application already it's reached 90, and reaching 100 will be very faster. But sometimes 75 to 80 will be surface number. It gives us some enough time to work on those issues. So when we speak about a when we speak about the timing, how the troubleshoot happens, so this brings the next topic like incident responses. So, right. So, incident responses, again, the important things when you are troubleshooting the issues. Let's say like you have SLAs and SLA was defined and your SLA says if there is a critical issues, you should react in a minutes or the hours, or there will be a very less numbers have been given, right? So when the critical happens, obviously when you reach the threshold of more than a 95 or right, that time it will be always counted as a critical. But if you, let's say like you have put a threshold earlier like 80%, and you understand my application going this is going to happen and it's very quickly, and you have a best reaction times, right? So that will be like a, you can prevent this to be a, you can prevent the incident to be happened. So that will bring us very best advantage, and it's give us some lot of time. How you can achieve it? So there will be a response, incident response in our SREs. Incident responses mostly like a incident command systems. So you can say like a, what is incident command system here? So it's nothing but like a, there will be defined rules or defined things will be given, and what they have to do at initial stage. Let's say like my application is reached out of memory and I should check what is the consumption and those details, right? So those kind of things will be defined in this, and also there will be a roles should be defined very clearly, and who is the incident commander and who is the lead it's going to be on, who is the operation lead. So those things will be very much defined, and with that you can have like a best troubleshooting scenarios, and everything will be maintained, right? And another important topic, whenever you are troubleshooting and you are fixing any kind of issues, please be documented, and that's help us on the very next time if something has happened. Obviously, we should do something like a root cause analysis, RCA they call it as, but keep a record for that why it's happened and what is happened and what went wrong, right? And what is the precaution we have taken and what can be taken and how we can avoid such issues, right? Those all things you can spend some best time and you can document it. So when it's happened again on the next time, so that will help us to troubleshoot such issues very quicker. Rather it's like a, again it's like a, we have to spend n number of time. So today you have troubleshooted a issue for 3 hours, and if we documented it, and it may reduce 3 hours to just 30 minutes, right? Mostly. And let's say like if you are not documented, another time if it happens, if it's and you are not there or someone is who all troubleshooted, so they are not there, so again your issue will be keep repeating, and you'll be facing the same issue, and you have to spend same number of time again and again. Or there will be like a dependencies. Let's say like you are today working on this issue and you have fixed and you forgot to submit your RCS, and someone else is facing the same issue tomorrow, and unfortunately you won't be there, right? Again they have to wait for you, or they have to do their own time spending. So with that what happens, they may, if they are good, yes it may be quicker, but sometimes if someone is like a, there will be some learners or someone is there, and that time it will be very difficult for them to troubleshoot such a large issues, right? That's why keep a proper records, so that should be help you to troubleshoot any kind of issues, and be shared with everyone. Like let's say like today's Confluence is one of the key tool for everyone, and we can put a Confluence page for the RCS, and tomorrow whoever is checking that, they can check that and they can use it for the further troubleshooting. All right. So that comes end of SREs and signals. So these are all the parts. There should be part of SREs, and there is lot. Again, SRE is not a single topic, or it's not like a 10-minute speech. So it's a very huge one. So we will be covering anyways on one another issue, how they are troubleshooting, and the key points we can add it. But if you would like to read more about it, so Google has a best document, best book for that SRE, and you can just grab that and you can study. I think there is an online version and you can refer that book. So that is a very huge and that can like a SRE Bible that's give very detailed thing. I'll try to attach it in the description, but you can try that if you like to learn complete SRE's concept. Right. Let's move on next. So next is logging and monitoring. So logging and monitoring is again very important topics when it's coming for IT or the operation side, right? So there is a lot of things we have to do it on the logging and monitoring, and there is a lot of monitoring we have to perform. So earlier there is like a single tool we were having when like a monolithic application is working. So we may have like an IQS and just enable it and it will alert us what is happening on your application. And we were just aligned with the single tools. There will be a competitor tools like an IQS and there will Jafix, right? So there is a tools were there, but that period was end, and now we have each and everything is more detailed, and there is a multiple tools we are using for multiple purposes. So let's say like if you want to just monitor the application performance and all, you have to collect the metrics as using metrics monitoring tools, and you want to collect the logs from the logs monitoring tools, and you want to go further down, so APMs, application performance monitoring, and there is a hell lot of things. Each and everything will be used given, and each and everything has a own tools, right? So what are the tools it's available now? So there is a open source tools. The open source tools, what I mean, so you can say like a Grafana or Prometheus is a metrics tool, and if you can use like a Telegraph, InfluxDB to collect, and there is a Monit. So one another tools are available when we are speaking about logging. So there is the help is there for open source. So that's you can use it, and we can just utilize those kind of tools, and we have to spend a lot of time again when we are speaking about just monitoring, but we have to spend a lot of time on that when it's coming open source. The key problem, there won't be any much support, but there will be a community support. So if you are so confident, you can pick that. But nowadays there is enterprise solutions are available for the monitoring. So when we are speaking of enterprise models, if you speak about logs, there is a Splunk, and for metrics are the Kubernetes monitoring and those things. We have tools called Datadog and similar tools, right? So there is a lot of tools are now in the market, so we can use based on our need. Again, each tool has their own drawbacks or they have limitations, so you have to very carefully pick those enterprise tools and you can use it. And another advantage or another key things, as we are using a cloud solution widely, and if you say like so I'm having most of my application on Azure only, and I have everything running on the PaaS solution. So in that case, so you no need to bother about your monitoring solutions because Azure or any kind of a cloud platform. So they give the by default monitoring options. So you can just enable it. So that will be collect what are the details you want. So with the less time, so you can bring those application monitoring in place, right? So yeah, so these are the solution available for logging and monitoring. You can pick and you can make use of it. But what are the things we should understand first, right? So as we know about there is a tools and we can pull the tools just in browsing a Google. But once we have a tool, what to monitor? So these are the things we should always monitor when it's so much important. So first thing, you should always keep eye on the node. As we are running on the Kubernetes, doesn't matter. Kubernetes just if Kubernetes is healthy, it doesn't mean our application will be up. There is even the issue will come from node. The underlying node may have some issues. So we should keep eye on the node health always. see how it's performing. Is there any issues? Even there is no resource issue, but there will be a shortage of storage, right? Yeah, or someone is dumping a some data on slash temp, and if you're using it, if your slash temp is 100%, your system may be restarted. Sorry, slash var is full, and your system will be unresponsive. So those kind of things you should very well plan, and you should monitor it. And that's why the node health is very much critical. Second thing is again the cluster CPUs and memory, and one another way like a node health and CPU memory is important. But let's say like you, as we seen in the last post, you have set the request resource quotas and limits, resource request limits you have set, and in that like your application is all of a sudden it's reaching a high number of thresholds, right? So your pod will be goes unresponsive, or it may get terminated, and some other pod may be utilizing a more memory, and your another application whichever it's needed thing, so that may goes failure state. So those are the things may be possible. So that's why you should always go on the CPUs and memory should be very much detailed monitoring. And again, as I said, the pod health check. So pod health check, like nothing but we have seen about probes, how it's important. See, one thing is like a pod may get evacuated because of the restart of resources, but there will be other issues also will be there. Let's say like your application is supposed to be running some commands or supposed to running something, but that file is not exist, or there is some short of the discrepancy. So in that time, obviously your pod will be goes out of health state, and your application will be down, right? So for that, you should enable the proper props and leaveness status, sorry, leaveness prop. And with that, you can identify what is happening and is it healthy or not. And you can take a decision based on the response code. Something like you are saying, hey, my application is getting down. So what you can do, you can enable the auto healing option, which is coming with the Kubernetes. You can say like restart always if there is any issues, right? So, or you can set a restart on failure. So it is will check, okay, there is a failure occur, and immediately it's once try to restart your pod. So that will heal us best, and it will be heal us quicker, but there will be again issues, right? It's not like always restarting the solution, but sometimes it helps. So always you should have a proper check on that. So networking should allow us to communicate throughout the cluster, the outside outbounds, right, ingress or anything. So though everything should be working properly. In case there is any issues, so that will be give us another issues. Like a troubleshooting network will be a very big topic. So yeah, so always we should be careful on the networking again. So next is application log. It's again correlated with the pod health check. So along with that, so application logs can be monitored, and there is any issues we observed, like with the Helk or there is a Splunk, we can identify there is any observabilities, so we can take a react on that. So these are the things we should be enabled, mandatorily should be monitored, and you can scale it up additionally whatever you want, but this 5 point should be always very much important, right? So what are the tools we can consider if you are so much interested in open source? We may suggest you can try with the Prometheus and Grafana, which is growing very faster for the metrics monitoring. And even the Grafana is now that's coming with the log monitoring along with Prometheus, or there is a prompt tile or something. So that has a feature, you can give a try. So you can just, this tool will be very much efficient for you. Or even you can try Help for the login, Elasticsearch, Logstash, and Kibana. So that will also give you the detailing logging solutions. So how you can collect the logs? So you may need to enable some additional options, Like you can create operators, or you can put some sidecar containers to collect your logs and parse to the any of the destination. It can be a Grafana, or it can be some storage, or it can be a Kibana, Logstash, or anything, or Splunk, or anywhere, right? So those kind of things, even you can do it. So again, you have to well architect on that. So anyway, we're gonna see about one another solutions in coming post. So hope that will be helpful. But this just for the consideration. So in this, we're gonna see the very first thing, like a pod health check, how you can do the pod health check, and we're gonna say some demo, and with that we're gonna say how it's a Linux probe help us to identify the issues and how we can troubleshoot very better, right? So as we've seen, like there is a three props in the Kubernetes: Linux, readiness, and startup prop. So Linux is like it's runs continuously, so it will be make sure it's your whatever the uh, whatever the definition you given, it meets the requirement. And if it's not matching the requirement, so immediately it's take the next action, like try to terminate, or it say like try to restart whatever the option it want to do, it does. Readiness prop, it's nothing but it will be making sure until your other key backends or related applications are up, it will be waiting for your application to serve to the users. And the startup is making sure your application is starting well and good, right? So next is, as we seen again in the last, so what are the types of props are there? So one thing check we can do, so command line, so you can run a command executes, like uh, so you can run some random commands to check. We're gonna see it in the demo. Or you can, if you are exposing any kind of HTTP request, you can just monitor and get the response code, which should be between 200 to 399. So why there is a 200 to 399? That's only considered to be healthy status, and that will give us the whatever the content we are looking. If something on 400 plus or 4XX, that maybe there is some server errors. If there is something like a 5XX or 500 plus, that may give some backend issues or something. Even in the application side, something is not proper. So TCP request, again, any kind of a TCP protocols, if you are using apart from HTTP protocol, 80 443 or 8088 443, those all counted as HTTP ports. If you are not using HTTP ports and you want to use any other ports, so you can use this TCP ports and monitor the applications, right? So this is about the health check, and a part of that there is a state, how you are managing your application. So as we seen the props or something very detailed in the YAML file, but again there is a people's, or sometimes we need to maintain our application declaratively or imperatively, right? So declaratively, if you are maintaining, it's a well and good always, but some worst case or some unexpected time, even we have to manage our application in imperatively. So what is difference? So when you are managing everything declaratively, you are defining everything as a YAML file, and any change you are making, you are not going to make anything directly, and it will be completely you are making the changes on the YAML file. So let's say like you are managing imperatively. So what happens on the time? So imperatively something you are editing, like kubectl is giving the options, giving options like edit, kubectl edit, and resource name. If you put, you can edit any values, not the arguments, but if it's a cluster related things, if you want to monitor, you can edit, modify it directly, right? So if it's continuous and tomorrow that application to anything happen to the application, that is not tracked properly, so we can't go back to the proper state. So always we should maintain everything properly. And we seen about the GitOps in the Argo CD side. So that is help us to manage our all the application state in the declarative manner. So with that, what we are achieving, everything will be stored on our JIT or any kind of a centralized place. and tomorrow even the complete cluster is vanished. So we have a files in our hand in our JIT. Just we have to connect another application and just deploy it using a single click. Otherwise, we have to spend a lot of time on multiple things that will postpone our times, and it may consume a lot of unexpected things, right? So we can avoid those things with this maintaining a proper state of management, right? So we'll see these two options, how it's been handled. So in the demo section. So for that, let's log into the our cluster and see what we are seeing here. So as I said in the last section, so we have prepared the props, and with that I'm gonna continue this demo also. So for that I'm gonna say like Linux execute, and I have created the file. So in this I'm just creating a pod, and I'm using a busy box here. And what I did, I just touched up one of the file, and I made a sleep for 10 seconds, and after that I'm deleting this file, right? So what happens with this? Sorry, I didn't delete the slide. So this will be deleted, and again I'm putting a Linux prop, which will be keep check of my application every 5 seconds. And what I'm doing, I'm trying to cat this file. So with that, what it's going to happen, let's see that. So let me create a kubectl play -f Linux X. Okay, so let's check the kubectl get parts. Okay, it's running now. As after 10 seconds it's going to be delete. Let's wait what it's going to do. Describe parts. So it's telling application command, it's delaying for 5 seconds and timeout and period, and there is our comments, right? So this is the leavenness and delay, and period will be keep on check. So there is a 1 success and 3 failures already it's occurred. So let's keep check the status. You can see it's restarted already. Why? Because the status is not present, right? So you can see the count again. It's restarted. Okay. So in that case, so we are purposefully did a restart. So it's supposed to be not happen, right? So in that case, it's happening. So let me do one more thing. So okay, you can see there is a error occurred because it's again getting restart. Now it's running. You can see the restart count is keep on increasing. As Kubernetes is meant to be restart always, if it's not restarting, you can enable the auto healing options by enabling a restart always option. You can put it in the YAML, so that will again help you to restart on some cases. So this will be keep try this, and this is not going to be never end. So it's going to be wait for certain time, and it's going to restart it, and this will be like endless loop. So how we can do this next? So some case, let's say like let's do one more scenarios. So let me put like this. I'm gonna do this. Let's copy this. I'm just copying it and I will do some purposeful failure here. So what is a so this is like a just for example. So what I'm gonna do, I'm gonna put some dummy failure command here, and let's try to launch the pod now. This is our new file. Sorry, QCTL. Sorry for the typo. Right. So this is failed because there is no option to see that. You can see there is okay. The pod is not changed. Sorry for that again. Okay. So now it's created. Gives it here the parts. There's a two parts here. Now demo, there is no touch part form because we have given this. So this is the command you can use it for the logs. Will be help you to get the pod logs, kubectl logs, and you have to give the pod name. So you can see we didn't given the command. It's failing, right? So you can see it's okay. That is another constance that is kept on the cross loop as it was keep on failing because there is a failure on our reference, right? So again here, so this demo also it's not serving anything purposefully as it's throwing a touch command is not found. Let's say like you want to modify this. So there is a by default capabilities you can use kubectl edit. Let's say like a parts and this pod name. You can view this YAML file, but some case you can't modify it here because that is not allowed in the last update configuration changes. If you are changing any count or some basic values, that is allowed in the kubectl, but if you are modifying any kind of argument or command line, you can't do it. So how we can troubleshoot? Let's say like you are new to this environment and you don't have a YAML ready, but you know fix it. You know how to fix this. It's happening production, such basic things or it similar thing. So what you can do quickly, right? You can do get and the pod name. You can say like output YAML, and you can put file called test demo.yaml, right? So with that, what happens? It will create a file for you test.demo, and in this you can modify this touch command where we have a touch command in this. I'm going to modify that OUCH, and let's save this file. And I'm gonna again do one more thing. I'm gonna change So as I said, until you are making as we are creating a same file name, so this will throw this error. So again, what you have to do in case if you are facing similar issues, so you have to delete that first, as it cannot be applied automatically. So if your pod is already failure state, you have to delete using delete, and then pod name. So now you can see the pod will be deleted. It's taking a little longer to clear, so let's wait. Right, so let's apply now. Let's try to apply this now. Now you can see this is test.demo, whatever the file we created from this output, it's got created. Right, so let's get the pods. So you can see this new one is running. It's CTL logs and then pod name. Oh, sorry, I didn't modify properly. Let's do one thing. Let's delete this and correct that. The mass execute demo. Demo normal. So let me modify this quickly here. So touch doing. As we have deleted already, I'm gonna apply this file now. Okay, let's get the logs now. Okay, now it's clear, and we should see the application should be good. So this is just for the demo purpose we have did this. But if you are facing any kind of issues and you want to modify that, please make sure you are deleting the part, then you are applying the new change. Otherwise, as we seen this error, so we could see similar errors. So that's one understanding, and also have a proper Linux prop. So with that, we will be serving a very best purpose. We can avoid this kind of a crash loop backups. So Linux prop, so it will avoid it. So let's one more time. Let's check the log. Let's say is there anything captured on the logs. By the default, it won't be. So how we can check that? So you can just describe it, pod and pod name. And if you're using any kind of a namespace, please append that at the end of the line with -n. As I'm using a default namespace, I'm not using any kind of a namespace name, right? So it is waiting and cross loop because of there is no file and it's failing. So again, let's check is there anything it's capturing on the event side. So kubectl get events. Also, you can use the command and you can see what is happening across. So you can see this is error is occurring on leave prodsec. So what is our pod name? kubectl get pods, and this is a pod and this is a failing. It's failing to pull the image. from the registry as it's giving some latest error. And other than there is a Leavness probe is failed because cannot open the /source testing as there is no such a file or something. So container bisbug failed and Leavness probe will be restarted. So this is how you can see the events also. So to check the events, you can use kubectl events command, right? So hope this is useful, guys. So we will be seeing on next video about further troubleshooting sessions on another one and also some interesting topics. Thanks for your time. Bye bye.